Okay, so let's discuss one question given in today's paper in Data Structures of Computer Science at Delhi University. Consider an n cross n matrix where Aij is 0 if I plus j minus n is not equal to 0, 1, 2, 1 is less than or equal to I and j is less than or equal to n. So first thing you have to notice counting or indexing. It does not begin from 0, it begins from 1. So if you're thinking that I equals to 0, j equals to 0, and 0 plus 0 minus something, and that is not equal to 0, 1 or 2, you need to forget that. So moving forward, excuse me, the non-zero elements of this matrix, that is the element Aij where I plus j minus n is less than or equal to 0 and I plus j minus n less than or equal to 2 are stored in a single dimensional array. So from this we know that there is some implementation of sparse matrix. So the zeros that we are shown in this example, these won't be stored. Instead we just have to store the numbers present in between. That would be these numbers. So now first question is asked, what will be the size of this one-dimensional array B? Let us perform case by case. So let there be 1 cross 1 matrix. Let x be some value. So A11, and let's check the condition I plus j minus n. So I is 1, j is 1, and n is 1. This is indeed equal to 1. So this would be a non-zero element. So the dimension of array B, would be 1 because one non-zero element, so one array will be stored. Let us consider 2 cross 2 matrix. So here elements 1, 1, 1, 2, 2, 1, and 2, 2. Let's consider for each case. First 1, 1. So this will be 1 plus 1 minus 2. That will be equal to 0. So this element will be non-zero. Now for 1, 2, 1 plus 2 minus 2 equals to 1. This will also be non-zero. With similar calculation, 2, 1 will also be non-zero because 1 plus 2, 2 plus 1, that will also give 1. And now checking for 2, 2. So 2 plus 2 minus 2 equals to 2. So in this case, all elements are non-zero. So dimension of size of B, size or dimension of B, that will be 4 because all elements are non-zero, so all elements will be stored. Now let's check for say 3 times 3 matrix. So here will be 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and 2, 3, 3, 1, 3, 2, and finally 3, 3. Now let's check all of these elements one by one. First 1, 1, 1 plus 1 minus 3 equals to minus 1, which is not equal to 0, 1 or 2. So this element will be 0. Now for 1, 2, 1 plus 2 minus 3 equals to 0. So this will be a non-zero element. Similarly for 2, 1 as well. Let me just highlight non-zero elements once. This is non-zero. This is non-zero. Now checking for 2, 2, 1, 3, and 3, 1. I plus j would be same in all these three cases. So 1 plus 3 minus 3 equals to 1, 2 plus 2 minus 3 equals to 1, 3 plus 1 minus 3 equals to 1. So these elements will also be non-zero. Now with the same logic, this time in this diagonal also the sum will be the same for I and j. 2 plus 3 minus 3 equals to 2, 3 plus 2 minus 2 equals to 2. So these elements were also non-zero. Now finally 3, 3. 3 plus 3 minus 3 equals to 3, which is not equal to 0, 1 or 2. So this element would also be 0. Our final matrix will look something of this sort: 0, some elements, some more elements, and then 0. Now this does not really give us the idea until and unless we move on and check the further matrices. Okay, so let's check for 4 cross 4 matrix. 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, and 2, 4, 3, 1, 3, 2, 3, 3, and 3, 4. Finally 4, 1, 4, 2, 4, 3, and 4, 4. Now which I will check all elements whether sum will be 0, 1 or 2 or not. So for first, 1 plus 1 minus 4 equals to minus 2. This is not equal to 0, 1 or 2, so this will be a 0. Now moving on for 1, 2. 1 plus 2 minus 4 equals to minus 1, which is not equal to 0, 1 or 2, so this will also be a 0. So this will also be a 0. And checking for 1, 3, 1 plus 3 minus 4 equals to 0. Okay, so this will be 0, and so all elements in the same diagonal will also be non-zero. Excuse me. Same can be obtained for here. Now in a similar way, the sum will be 5 minus 4, sum will come out to be 1, and in this case sum will come out to be 2. And in this case the zeros will be these. So our final matrix will look something of the order 0, 0, 0, 0, 0, 0. We know 5 cross 5. This is something that was already given to us in the question. If we move backward, we see that there are three. We can see all these zeros, so we don't have to calculate anymore. So now we check the pattern and then see if we can calculate the number of zeros from that pattern or not. So for 3 cross 3, we received something of this sort. For 4 cross 4, we receive something of this sort, and for 5 cross 5, we receive something of this sort. Now for n being greater than 3, can you find any pattern for the zeros, that in a given matrix how many zeros are occurring? So let's see, for 3 cross 3 we can see there is 1 0, there are 2 zeros. For 4 cross 4 there are 6 zeros, and for 5 cross 5 there are 1 2 3 4 5 6 12 zeros. And now to simplify things further, let us assume zeros only from the corner. So this will be 2 times 1, because there are two corners and at each corner there are fixed number of zeros, and this 6 will be 2 times 3 and 12 would be 2 times 6. Now can you guess any pattern that occurs in further? What I can say is that this number 1, 3 and 6, if I look closely, this is 1, this number is 1 plus 2, and this number of zeros can be represented with 1 plus 2 plus 3. So with this pattern in mind, I can say that the number of zeros at a corner is, no, this is sum of n natural numbers, right? This is sum of 3 natural numbers, sum of 2 natural numbers, sum of 1 natural number. But here n was 5 and here n was 4 and here n was 3. So it will not exactly be n. The sum will be number of zeros at corner will be sum of n minus 2 natural numbers, where n represents the dimension. And since we have two corners, so total number of zeros in a matrix would be this number times 2. Now if you recall any math from high school, you remember this formula for sum of n natural numbers is n times n plus 1 upon 2. So here when n is given to be n minus 2, I can simply put the formula, substitute the value of n with n minus 2, and this will be equal to n minus 2, n minus 1 upon 2 times 2, which will further come out to be n square minus 3n plus 2. Total number of entries in a matrix or in a 2D array, that will be n square, right? 3 cross 3, 4 cross 4, 5 cross 5. So this will be 90, this will be 16 entries, this will be 25 entries. You can see for yourself 1, 2, 3, 4, 5, 6, 7, 8, 9, and then these will come out to be 16, these will come out to be 25. Okay, now what? Well, we have got number of zeros in the matrix that we definitely want to store. We got total number of entries in the matrix, that is n square. So what will be the size of array? Size of 1D array. In this 1D array, we won't be storing zeros. We will only be storing non-zero entries. So for that simple arithmetic, what will be the size of 1D array equals to number of zeros in total number of entries minus number of zeros in the matrix. So that would come out to be n square, total number of entries, minus n square minus 3n plus 2, that will be number of zeros in the matrix, which comes out to be n square minus n square plus 3n minus 2 equals to 3n minus 2. This will be the size.